Use Simpson's rule with 5 ordinates to find an approximate value for the integral of log 3 plus x squared between 1 and 2. Show your working and give your answer correct to 4 decimal places. Use your answer to part A to deduce an approximate value for the integral of log of 1 over 3 plus x squared between 1 and 2. So let's have a look at this then. Part A, we need to use Simpson's rule. So let's have a look at that then. Let's just paste the formula in from the formula booklet. So let's do that then. So this is what we need to work out. Now, 5 ordinates, so there's 4 intervals, so n is 4. So let's put n as 4 in here. So let's put that in, 4 intervals, so n is 4. So the odds will go up to y3, won't they? So we won't need that. And the even integers in between the first and the last will go just to y2. So we can get rid of all that lot, can't we? So, and then n is 4, so let's just put that in as well while we're at it. So pen, y4, 4y3, so we'll put that in there, plus 2y2. B minus a, b is 2, a is 1, so let's put those in as well, 2 minus 1 over 4. Which is equal to 1 over 4, or a quarter. So we've got a quarter over 3, which is a 12th. Let's put that in as well then, before we do the calculation. So we've got a 12th here. So we need to work out the y ordinates. Let's write down the x ordinates. Between 1 and 2 with 5 ordinates. H is a quarter, so x0 then, x1, x2, x3, and x4. So let's write down these. So we start from 1 and we increment in 0.25, so quarters. And 2.00, this is 1.00 of course. So the y ordinates now. So we need the log. Here we're working out the log of 3 plus x squared. With 5 ordinates to 4 dp, so if we work to 6 dp we should be okay. ln of 3 plus x squared. ln bracket 3 plus x, which is 1 in the first instance, squared, equals natural logarithm of 3 plus x squared is there. Just move this over a bit. So equals 1. And it's 386294. Next one. What we do is we change the 1 to 1.25 now. 517871. 517871. Okay. Next one is 1.5, isn't it? 658228. 658228, 1 point. Next one will be 1.75 now. 802122. 802122. And then that was y3, wasn't it, here? And then y4 when we put 2 in. $945,910. So there's all our numbers then. So we can do the calculations. So answer is equal to 1/12, and then we've got the first and the last, y0 plus y4. Okay, plus 4 lots of y1 and y3, which are these two. and then we've got plus 2 lots of y2, which is this one. So that's what we're going to tap in the calculator. So we've got, let's just work out this constituent part in here. So we've got the first and the last, 1.386294 plus 1.945910, 945910 plus 4 times, bracket, these two then, 1.51781871, 517871 plus 802122, 1.802122. It was 4 times those two, and then it was 2 times this one, plus 2 times this sole number here, 1.658228. So that's the number inside, equals, let's go back and get rid of the brackets, probably, I think, and delete that bracket, equals 19 point, so this number in here, I'm going to write it down, is 19.928632. 928632, which equals 928632, and now divide that by 12. Now we're doing it to 4 dp, aren't we? 6607. 1.6607, and that's the 4 decimal places. Okay, good. So that's that bit done then. So now let's move on to the second part of the question. Hence, find the approximate value of this. So we'll label that I equals, and the answer is the answer from above. So part B, here I is equal to the integral between 1 and 2. Using properties of logs, this is to the minus 1, isn't it, when it's underneath? You move it up, it's to the minus 1. And the power rule means the minus comes down. Minus ln of 3 plus x squared dx, which is simply equal to minus the integral, minus answer. So we can say that's equal to minus 1.6607 to 4 decimal places.